the area rule is that from primary school you were taught that the area of a triangle is half base times perpendicular height. Now that formula was generally used, okay, if you were given the base, you were given the height. But there are some cases where you may not be able to determine the height of a triangle, okay? In a case where the height of a triangle is unknown, then it becomes a challenge, okay? So the area rule can be used to determine the area of a triangle. That is if you know one angle and the two sides that form that angle. So you won't need the height at all. You just have to know one interior angle and the length of the sides that form that angle. So according to the area rule, it can be written in three ways. Okay, so the area of any triangle ABC, okay, it can be calculated by the formula. If you are given angle A, let's say you are given angle A. Angle A is given, then the length of AC must be given and the length of AB must be given. So in that case, the formula becomes half BC sine A. Okay? If you are given the size of angle B, then means the length of AB must be given and the length of BC must be given. And the formula for the area of the triangle will become half AC sine B. If you are given angle C, it means the length of BC must be given, the length of AC must also be given. And the formula becomes half AB sine C. Generally, you are going to see me writing it like that. Half AB sine C. Okay? But you need to know that it can also be written as half BC sine A, half AC sine B. Okay? This is very easy. But I want you to be aware that the area rule, it has got some relationship with some questions on analytical geometry. Questions where you calculate the angle of inclination, you may be asked to determine the area of a triangle. And in that case, you won't have a perpendicular height, but you might have an angle. You must remember that you may need to use the area rule. Alright? Then the proof of the area rule, as in the past, like the sine and the cosine rule, you draw a triangle in the first quadrant and make sure that your angle A is at the origin. Okay? Already we know how to calculate this perpendicular height. We have done it for the area rule, the sine rule. The height H is going to be equal to C sine A. We have done it already. Okay? The height H is going to be C sine A. So since H is going to be C sine A, if H is not there, it means all I need is the length of C and the size of angle A. So if I write my formula, half times base times perpendicular height, this perpendicular height is going to be equivalent to C sine A. Okay? That's going to be equivalent to C sine A. So you substitute it there. Then you identify your base. In this case here, my base is going to be the length B. That will be my base. Okay? Which means the height H, which is C sine A, the formula becomes half BC sine A. Now, that's going to depend on the reference angle you have. If your reference angle is C, then the formula becomes half AB sine C. If the reference angle is B, it becomes half AC sine B. Okay? So that's the derivation. Okay? So it's very simple. If you understood the derivation of the area of the sine rule and the cosine rule, then you also find the derivation of the area rule very, very easy. They are almost the same. Okay, I also want you to be aware that you can also derive the sine rule from the area rule. Okay, you can derive the sine rule from the area rule. If you read widely, you look at some textbooks, you can also find the derivation of the sine rule from area rule. Okay. Our angle there, angle B, 70 degrees. Then we are given the length of AB, the length of BC. So if I use the small letters, Okay, for this triangle, this will be small b, that will be small a, and that will be small c. So I know the length of the small a and the small c, right? And I'm also given the angle between them, right? So I can write my formula for area rule here, right? It is area of triangle ABC is going to be equal to half. Since I'm given A and C and I'm given the angle B, it will be half AC sine B. It's not difficult at all. Hey, can you put that away? Do I have to tell you that all the time? So this will be equal to half times A, that's 4, times C, that's 30, sine 70 degrees. Right? So it will be half times 4 times 30 times sine 70 degrees. What answer do you get? 24. So it will be 24,43 square units. This is area. Okay? Oh, in this case it's given a centimeter, so it will be square centimeters. Okay? 24,43 square centimeters. Okay, that's very easy, isn't it? Huh? Very simple. Right. Allow me to carry on. And carry on. Yes, it's part of trigonometry. That's the last aspect of trig. But we still have got what I call 2D and 3D problems that we have to do. But we will do that after the examination. Okay? Trigonometry is the longest topic. Okay? In your FET test is the longest topic. That's why when you write your maths paper 2, it has got lots of marks. Okay? Like for your end of year examination, it has got almost like 50. I allocated almost like 55 marks only out of 125 of trig. Around 50 to 55. So you have to know your trig. Even when you write in a trig, it's in paper 2, it has got almost like 33% or so. Okay? It's a major topic. Alright, so let's move on. So here, we are now doing number 3 now. Now, it's not always that you'll be given an angle, like in this case, we are given an angle. We know the length of HJ, but the length of IH is not given. We don't know the length of IH. Right? In that case, we may have to calculate the length of IH. To calculate it, we have to use first the sine rule, or if possible, cosine rule. But let's start with the sine rule. Okay? We can't find the area here of this triangle without knowing the length of IH. Okay? We have to know the length of IH. Right? So let me label. This will be small h, that will be small j, this will be small I. Right? By now we should know how to label. Right? Then, since I don't know the length of IH, okay, I don't know it, means I have to calculate it. Okay? I have to calculate it. Another way would be, I might need, if possible, to calculate maybe a new angle. Okay? I might have to calculate a new angle, and in that case, it means I might not need to use this one here to calculate the area of that triangle. So J is opposite this angle. I don't know that angle. So I can't use the sine rule to find angle J. Okay, I can't. But I'm given the length of JH, so I can calculate the size of this angle using the sine rule. After calculating the size of this angle, I can calculate the size of J Because I know that the sum of angles in a triangle add up to what? 180 degrees. Then, after that, I can be able to calculate IH. Or, if I calculate the size of this angle here, I won't need to use 52 degrees. I'll just use the size of this angle together with JH and IJ. You see what I'm saying? I think that would be the easiest way. So let me calculate the size of this angle I, then I'll calculate J, then I'm done. I'll calculate my area. Right? So if we do that, it means I'll say in triangle IJH. Okay, which one starts with HIJ? Yeah. In triangle HIJ, right? If I use the sine rule, I have to write it as I over sine I is going to be equal to H over sine H. So that would be my sine rule. Okay? The question is not straightforward for us to cover the area. We have to go higher sine. Okay? So from here, my small I is 21. My sine I don't know it. I don't know the size of I, so I'll just write sine I. My H is 17, and my angle H is 52. So this will be sine 52 degrees. Okay? Now, you have to know how to solve the equations. When they it, so you cross multiply there. This becomes 21 sine 52 degrees is equal to 17 sine I. Okay? Then it means that if I divide both sides by 17 there, divide both sides by 17, it means my sine I is going to be 21 sine 52 degrees all over 17. Okay, please. I don't want you to stress yourself trying to convert that 21 sine 52 over 17 to a decimal. Let's not do that. All we have to do is eliminate sine on the left, introduce shift sign. Where is your method book? Right? Let's introduce shift sign. So, this is very interesting now. So this becomes angle I is going to be shift sine of 21 sine 52 degrees over 17. Okay? Instead of converting 21 sine 52 over 17 to a decimal, I decided to say, okay, since my calculator can incorporate everything, let me not do that. Let me calculate my angle and put my ratio as 21 sine 52 over 17. You can put that in the calculator and you get your answer and round it off to 2 decimal places. Straight away you get your angle. Can you do that, please? You press shift sign, then fraction option, 21 sine 52 over 17. What? 76. Okay, so angle I is 76, 76 degrees. Right? So that's the size of this angle. It's 76, 76 degrees. Alright, then, since I made the decision that I'm going to calculate angle J, I'm going to calculate it. When I calculate it, then I can calculate the area. So I'll just write here, angle J is equal to 180 degrees minus 52 degrees plus 76,76 degrees. 51,24 degrees. Right? Now I'm smiling because I know that I'm almost. You have to put a reason there. Yes, I'm going to put it. So your reason here, okay, well, this is tricky. You may not be given a mark, but just to be on the safe side, you must write it. Sum of angles in a triangle. You must give your reason there. Right? Then I'm almost done. So let me just do it here. Allow me to do it here. So area of triangle HIJ is going to be half IH times sine J, okay, which will give me half times I, which is 21, and my J, my H, okay, 70, okay, times sine 50 what? This is 51,24. And my final answer will be what? Half times 21 times 70 times sine 51,1. Yeah? 139,19. This is square meters. No, there are no units. There are no units, so it will be square units. Right. So I'm done. So this will be your final answer. Okay. Right. Please take note that